Hi class. So here is the fifth type of precipitation that we're going to take a look at, sleet. You're going to take a look at this picture and you go, didn't we just draw this picture? And the short answer is, yeah, kind of. We just did kind of draw this picture. There's going to be one huge difference between these figures, and we'll get to that in just a little bit. Okay, so with sleet, again, you start off with a cloud with ice crystals in it. Those ice crystals are forming via the Bergeron process, and those ice crystals are going to fall below the cloud base, and they are going to encounter a layer of air that is above the freezing point. So here we are, where the temperature of the air is above 0 degrees C. So above this line, the temperature is below the freezing point. Below this line, the temperature is above the freezing point. So these ice crystals are going to once again fall into a layer of air that is above freezing. So ice crystals fall into an above freezing layer of air. Oop. Okay, and just like before, those ice crystals then are going to melt into raindrops. Okay, so again, this is pretty much how rain forms in the mid-latitudes. It often starts off as ice crystals and melts into raindrops. Okay, now down here at the surface, once again, we've got our tree, we've got our red sports car, we've got our power lines or telephone lines, and so once again, everything at the surface here is going to be below the freezing point. So we're going to have a layer of air that's in contact with the surface that is below freezing. Okay, so here's the big difference. Okay, this sub-freezing layer of air that we find at the surface is going to be deeper than it was with the previous form of precipitation, which was freezing rain. So again, in this layer, the air is, in this middle layer here, the air is above the freezing point, but this layer of air that's in contact with the earth is, the temperature is below the freezing point. Okay, so we have a deeper sub-freezing layer of air. At the surface. Okay. So being a, so all the objects at the Earth's surface, again, are going to be equal to the air temperature. They're going to be below zero. Okay. And so the key here, the big difference here is that as these raindrops fall through the sky and they enter this sub-freezing layer of air, now this is a much deeper sub-freezing layer of air than we had with freezing rain. Okay, so being deeper, a deeper sub-freezing layer of air okay, this time it's going to give the raindrops time to refreeze. Okay, so being a deeper sub-freezing layer of air, the raindrops have time to refreeze. Okay, and they're not going to refreeze into ice crystals, but they're going to refreeze into what we call sleet. Maybe a more graphic description would be ice pellets. So these raindrops have time to refreeze into ice pellets. Much easier to deal with at the surface than freezing rain. Easily swiped off your windshield, shoveled, or even swept off sidewalks. So this is so much easier to deal with. Once again, all of these objects at the surface are going to be below the freezing point. But because of this deeper sub-freezing layer of air, the raindrops have time to refreeze and will not be coating the surface with a layer of ice. Okay, so if I bring in the previous figure here, you'll notice that the big difference here is this sub-freezing layer of air. So with sleet, let's see, I think I've got this over about as far as I can. So with sleet, you've got a much deeper sub-freezing layer of air that's in contact with the Earth's surface, which gives the raindrops time to refreeze into ice pellets. With freezing rain, you have a much shallower sub-freezing layer of air. So when the raindrops fall into that sub-freezing layer of air, that shallow sub-freezing layer of air, they don't have time to refreeze. They only have time to become super cooled. And so when they fall to the Earth's surface, they're going to coat everything with ice. That's freezing rain. Okay, sleet or ice pellets, the sub-freezing layer of air is deep enough to give them time to refreeze. Okay, so that's the big difference. Now, the kind of the unknown here, there's no magical number in terms of how deep does this sub-freezing layer of air need to be to create sleet versus freezing rain. There's so many environmental factors that go into this. It's difficult. It's impossible to pick a single number. Okay, and so it just depends on what are conditions, how cold is it at the surface. I'll just give you a personal experience. When I lived in Lincoln, Nebraska, we had freezing rain and the temperature outside was, I think, 9 degrees Fahrenheit. And that's really, really cold at the surface. You'd think it would be snow or at the very least sleet. But that really cold air at the surface must have been a very shallow depth in order for us to experience freezing rain on that particular day. So again, there's no magic depth to determining whether it's going to be freezing rain or sleet. Okay, all we know is that if the deeper that sub-freezing layer of air is at the surface, the more likely it's going to be sleet. The shallower that sub-freezing layer of air at the surface, the more likely it's going to be freezing rain. Okay, so next we cover hail, the last one.